That works. Okay. So chapter 10 is connecting desktops and laptops to networks. So if you're familiar with networking, this should be a pretty easy chapter for you because a lot of it has to do with different networking protocols and the way things work. So we're going to talk about configuring a computer, connecting it to the internet, working with internet clients, file and printer clients, and then a little bit about troubleshooting problems that come up because they always do. So when we look at configuring a network connection, the first thing the book wants you to know is what a protocol is. So a protocol is a set of rules. It's a standard. In networking, we talk a lot about protocols. We talk about TCP and UDP and HTTP and all these different crazy acronyms. But all it means is it's a set of rules so that different networks can talk to each other without there being any trouble. So software and stuff has to work together. And these things get bundled in what we call a protocol stack so that we can tell where one thing's responsibilities start and another thing's responsibilities, how they start and end, I should say.
So it's safe to put my credit card information on something that does not say HTTPS?
Yes, absolutely.
Just making sure.
Go for it. What's this? Why are you talking like this today?
To make sure my voice gets cast to you.
Okay.
It's basically
somebody reboot Christian. Omar, that's your job. So the TCP/IP suite, if you've been through fundamentals of networking or maybe Net Plus, then you're familiar with TCP/IP. So there's different protocols within it, but the TCP is one part and the IP is the other part. So we have 4 layers to that: the network interface, the internet, the transport, and the application. So this is what makes all the computers all over the world with all their different brands and all their different configurations work together to form the internet as we know it. So that is the importance of TCP/IP. So the TCP part of that is managing reliable delivery of messages. So TCP is connection oriented. You hear that quite a bit. So if something fails to get from source to destination, it makes sure that it gets resent. So that's not a problem. And there's several different sub-protocols underneath TCP. IP is delivering the packet from the source to the destination on the network. So a packet's just a chunk of data, and it's formatted in such a way that it knows what a packet looks like, so it can distinguish one from another one. And then we have an internetwork, which is just a network of networks, or as we sometimes call the internet. And those routing protocols are what's used to figure out what's the best way to get from the source to the destination in the best manner, in the most efficient manner. So this is where we need an IP address, right? If we don't have an IP address, then we can't talk to other things on the network. And that's what a lot of this chapter has talked about. We've talked a little bit about IPv6 versus IPv4 previously. IPv4 is a 32-bit address, so there's not that many of them. IPv6 is a 128-bit address, so there's a whole lot more of those available. As more and more things have IP addresses so they can talk on the network, our mobile phones, our refrigerators, our Kindles, our laptops, our smartphones, everything needs an IP address to communicate. So,
what about bathrooms?
What about bathtubs?
Bathrooms.
Bathrooms.
Don't they need an IP address?
Okay. So IPv6 gives us more addresses. They've wrapped some things up in it that make it a little bit more secure. Since everything's on the internet now, we need all the IPv6 addresses that we can get. So the network adapter, which in a traditional computer or in a lot of devices we'll call a NIC, a network interface card, is the thing that gets the IP address. So that can be your modem, for example, that you get from your internet service provider. It has an IP address on it. It also gets a subnet mask. And the routing protocols are used based on that information to figure out how to get from point A to point B. And every device on the internet has a specific unique device, which we would call a public address. And when you look through Windows 10, this is what the dialog looks like. If you've got a choice here between IPv4 and IPv6, and they're right up next to each other. So you can go look at your IPv6 properties just the same way you would normally go look at your IPv4. And especially the larger the organization you work for, you might see a lot more of that. So we've used IPv4 for decades. We had about 4.3 billion possible IP addresses, but we have way more people than that in the world. So an IP address looks like this, and we pronounce it 192.168.1.134. They call that dotted decimal notation. Each part within that is called an octet, and they're either from the number 0 to the number 255. And anything outside of that range is not a real IP address. They use the very, very last block of addresses in 2011. So if you go to the status of your LAN connection, then you can often see your IPv4 address and your IPv6 address that's been assigned to your network adapter. In OS 10, you're in the network under preferences, and you can see your IPv6 address and your subnet mask. Change out your addresses there if you need to. And in Ubuntu, what we talked about last week, we have the same thing with our IP address and our subnet mask. We need all that information if we want to be able to get on the internet. So we're transitioning now to IPv6. This is 8 groups of hexadecimal numbers that are separated by colons. This would essentially give us 340 trillion addresses. That's a number so big I can't even comprehend it, but we have a lot more options, let's say. So an IPv6 address looks like this. So here we have our groups separated by colons. They have the number 0 through 9, or the letters A through F in hexadecimal format. We'll talk way more about this in fundamentals of networking when you get to that point. So then they've shortened it. You can shorten it, take off some of the leading zeros, and if you were to write that in binary, it would be expressed by this. So this is actually what the computer reads, but thank goodness we don't have to know that. We can just say something dot something dot something, right? So which addresses can you use? You can use a public address, which is something that on the internet, they get a public address. It's unique to the whole internet, and there's a company called IANA. They're the people that determine who get what addresses. So for example, at your home you have a router. That router has a public address. It doesn't share it with anybody else. It's just its own address. And all the computers in your home have a private address. If they need to talk to the internet, they have to go through the router because it's the one with the public address. So we end up using different kinds in our home and business networks. We have a range of private IP addresses. Those are the ones reserved for the things like we just said on the home network that aren't going to, like they're not the router. They're things within the home network. So when you see an address that fits through one of those ranges, you know that it's a private address. So you could expect that to come up on the test when we take it. So a NIC gets an address through a couple different ways. The first one is static, which means an administrator goes in and types in the address. They've already figured out what address they want it to have, so they go to the settings and they go type in the address and all that information. Then we have automatic address assignment. So first we have automatic IP addressing using DHCP. So that's dynamic host configuration protocol. It's dynamically getting its address from some higher power that's establishing what those addresses are. And then we have a PIPA, and a PIPA is the address that when your computer can't get to the router for some reason or can't get to the thing that's giving out IP addresses, it just assigns you kind of a random number. So you have an address, but it won't really get you anywhere outside your local network. So we call that an PIPA address. When you're looking at your configuration settings for IP, you've got the IP address, the subnet mask, the default gateway, which is your router, and then you have the DNS server. So the DNS server is going to resolve IP addresses with host names. So if you go to tstc.edu, you're actually going to the web server that has the pages that have tstc.edu on it. We refer to that as DNS. But all those settings are common things that you're going to have set up. Here's an IPv4 address with a subnet mask. This is a process of applying the subnet mask to it and getting IDs. You're not going to need to know how to do that in this class, but if you're in fundamentals of networking right now, I think no matter who your teacher is, that's being covered. But the subnet tells you what part of the network the address is located on. So it tells you a little bit more information logically about the network. If you want to see your IP configuration of your computer, you go to command prompt. How do we get to command prompt?
So you press the Windows button,
okay?
and you type in command, and it comes up on the shortcut thing.
Or you say CMD, right? CMD, that's the quick way, and hit enter and you get to that, okay? So in this case, they've done the command ipconfig/all. So ipconfig is a command, but it doesn't give you that much information. It doesn't give you your DNS servers. But this ipconfig/all gives you a whole lot more information about what you're seeing. So if you do the same thing in OS 10, you end up with a screen just like this. Their terminal is a little inverted color-wise. And here we call it ifconfig for interface config. We get the extra information. In Linux, same thing, ifconfig. Here we get our different adapters and all the information that we need about those. So those are really, really common troubleshooting tools. If you can't get on the internet, you can't access a web page, the very first thing you should do as an administrator is go pull up ipconfig and make sure you have an actual address that will get you somewhere. Because if it starts with a PIPA starts with 169.254. You see an address that says that, you're not getting anywhere. You've got to figure out why your computer can't find an address first before you can do anything else. Now, connecting to the internet, there's lots of different ways to do it. A connection to the internet is a WAN connection, a wide area network connection. We need as ISP or an internet service provider is the organization that gives us access to the internet. So that's your Longview Cable, your Fidelity, AT&T, Verizon, HughesNet, Zoom Broadband, all those are ISPs in this region that give us access. So here's what it looks like when we connect to the internet. So we have a single client. We also have a business LAN. They're both connected to the same ISP that connects to the internet. What's the difference between being a single client and being a business to the ISP? To these people, what's the difference between the business and the client? Who pays more? Who pays more for their bill? A single person or a business? A business, right? If this guy breaks and this guy breaks, who gets fixed first? The business. Honestly, beyond that, that's pretty much it, right? There's going to be a little bit different equipment behind a business. They're going to have firewalls, they might have multiple routers, they might have VPN connections and all this fancy stuff, whereas a single client probably doesn't, unless they already they know what they're doing. But either way, a LAN is a single network that covers a building, a home, an office, a campus of some kind. It can be wired, it can be wireless. There's lots of similarities, no matter whether it's just a single person or a business. Some people still use analog modems for connection because, hey, if you live in the middle of nowhere, that might be your only option, right? A lot of times businesses use dial-up as backup connection too because it's inexpensive. If they have something that needs to be transmitted at 5 o'clock every day, they'll have a backup phone line just for that purpose. That's not uncommon. So this uses the traditional phone system. It's very inexpensive. It's very slow speed-wise. On campus, we're used to at least 10 megs or so connection. And because of the volume of people on it, it's really not all that fast. But this is considerably slow. But you can't use voice and data on the same line, right? I know my parents had to get me a completely separate phone line when I was young once I figured out what the internet was and that I could download things on it because I would just I would pick up the phone line all the time, completely unapologetically.
Yeah.
Other different kinds of wired access, you can use ISDN, DSL, which is what we normally get through AT&T or Verizon here. That's using the phone line as well, and then through cable service. So with DSL, you could talk on the phone and use the internet at the same time, and that was a really big deal. And it was faster than dial-up, so lots of people moved to that. Cable uses your cable TV connection and using coax because, hey, it's really all just data, whether it's coming from a satellite in the sky or coming from another network, it's just treating everything as data. Everybody in the neighborhood shares the same lines. and it transmits over several different channels simultaneously, which is why you can change channels on your cable box. So when you're connecting to a wireless WAN, there's lots of different wireless points in between you and where you're going, but you're probably using some sort of satellite or a cellular hotspot to get your information across, and this is normally referred to as a WWAN, a wireless WAN. The same thing when you have a satellite. So the problem with satellite is latency, right? Latency is delay. So it takes time for stuff to get to outer space, understandably. So you might end up with a delay. Like, for example, if you ever watch the news and people will say, where was so-and-so at such and such place, and she's right here on the action. And the person is smiling because they know that they're on, but it takes 30 seconds for them to actually start talking because there's a latency between the 2 points. And sometimes it's funny to watch the person stand there and smile, even though they don't know they're supposed to be talking yet. Wireless LAN connections, this is where we see our Wi-Fi standards. Again, in networking, we'll go in this in much, much more detail. It doesn't go generally further than a few hundred feet. If you want to go further than that, you have to have access points that you put around the building for that. It does not directly connect to the ISP. It connects to the router, and the router connects to the ISP. But Wi-Fi becomes faster and more secure as time goes on, and also comes with its own kind of set of problems. A VPN is creating a secure access within an unprivate network, an unsecured network. That unsecured network is the internet. So you're basically making a private tunnel inside the internet where things are encrypted and things are secure going from source to destination. So a lot of times you'll see things like this if you have branches and you have a headquarters, and those branches need to transmit information to headquarters. They'll do it through a VPN tunnel so that they know that their data is not getting caught, it's not getting compromised on its way. So here's what a VPN looks like. So you've got a remote worker using a laptop from home or from a coffee shop maybe to access files on the corporate servers. And there's a tunnel between them, between the laptop and the corporate VPN site that you can see here going through the internet, just to make sure that none of that data gets compromised. So the name of this course is Implementing and Supporting Client Operating Systems, right? We've talked about all these different versions of Windows. We talked about OS X. We talked about Ubuntu. Apparently we need to talk about it some more. But all of these different operating systems are for the purpose of being used as a client, okay? So let's talk for a second about web browsers. So web browsers browse websites, okay? Web browsers use HTTP. That's the protocol that they use. That's the really common one. So there's code that dictates what a website's supposed to look like. The web browser is the thing that says, I'm going to take this code and make it look like the website. And it doesn't matter if you're using Google Chrome, Firefox, Safari, Internet Explorer, Microsoft Edge. That website generally looks about the same. All the stuff is in the same place, the colors are the same, the text is the same. So that is the power of a web browser. Some common features of a web browser, some of these we've talked about. Active search, add-ons, auto-filling, doing automatic updates, bookmarking things you want to save for later, maybe managing your passwords, throwing in some RSS feeds so when new information comes up you get an alert about it, browsing with multiple tabs in one window. Y'all are all fairly young, but I remember when that came out, it was like a really big deal. I don't have to open 15 windows, I could just do it all in one window. That was amazing. And then maybe some accessibility features like zooming. Here's Google Chrome. It's an example of that. This is my personal favorite with the multiple tabs across the top. Although I've noticed over the last year or two that all the browsers, like, they pretty much look exactly the same. When you open them up, they all kind of have the same shape to them and the same shading. But there's Google Chrome. There's Mozilla Firefox. It looks a little bit different. Some people prefer Firefox. Microsoft Internet Explorer. That's the browser that you go to download other browsers, right? Yeah. So here's what that looks like. You can see they all have very, very similar features and similar looks to them. And then Microsoft Edge, which is what came out with the newer versions of Windows. Web browsers have some security features in them and some things that can come in handy as an administrator of computer systems. So we have cookies. Those are the little files that save things like things that you put in your shopping cart or text that you typed in. Then we've got browsing history. A cool example of a virus, not cool that I want it, but a cool example of a virus would be to send your search history to an attacker. Like they infect your computer and it just sends your search history over. That could get people in trouble. Private browsing means that no history is kept. Sometimes that's called private mode or incognito mode. That's a security feature. Maybe remembering passwords for you. The thing you should remember is a lot of those are stored in plain text. So especially on these computers where they're shared among different classes, if you save your password there, it's very possible someone could just go find your password. So you don't ever want to do that in a shared computing environment. And then pop-ups, normally blocking pop-ups is going to be helpful. Here's where we change those settings in Chrome in content settings. Lots of different options there. In Firefox, we have some different privacy settings as far as accepting cookies and little things like if a website's tracking things on me, like my location, tell me about it because I want to know about that. That's actually a really cool feature. If you ever pull up a map on any website, it's going to try to look up and find your location. Some will try to look up and find your IP address, find your internet service provider, and maybe you don't want everybody having that information. In Internet Explorer, there's some privacy settings as far as cookies. There's some cookie settings in Microsoft Edge. And of course, as we talked about, Cortana has a lot of tracking and things within it, so that might be something you want to be aware of when you're using that. Here's Google Chrome with the history page. Very detailed, every single site that you visited. Keep in mind that stays on your computer until you delete it. That's all I'm going to say about that. You can even, in some browsers, in most browsers, set so that every time you close the window, it deletes all the things that you did when you were within it. Now keep in mind, that still stays with your ISP, like you still called up a web page, so they could still find it. This doesn't make it unfindable. But a lot of times people prefer to not have their browsing habits stay on the computer. Here's the history page in Microsoft Edge where you can see the history and when it last happened. Here's an example of private browsing. You can normally see, this is Google Chrome. It shows a little suspicious looking guy with glasses and a hat. And this has a little mask so that you know that you're in private browsing, which means what you're doing is not being tracked or recorded. And those are not always for malicious purposes. Like a lot of times I'll do that if I want to buy something for my husband and I don't want him to know about it. Then I'll make sure that I don't keep any tracks on my computer in case he happens to use it. Chrome has some different password settings in it. You can set up a Chrome profile and then have it and remember your passwords no matter where, as long as you log in. So that's a nice setting. You can set a master password over all your passwords so they aren't easily or accidentally erased with Firefox. There are other third-party applications, LastPass and Dashlane, that do the same thing. They're password management softwares. If you have a lot of passwords, you might be interested in that. And here's Internet Explorer autocomplete settings. So you can have it you can start typing and let it try to autocomplete your thought. Autocomplete can get you in trouble sometimes. You can manage passwords in Microsoft Edge as well. Okay, if I teach you nothing else in this chapter, this is the thing I want to teach you. Let's talk about email. How do you check your email? This is the part where you talk back to me. Open email.
Yes.
How specifically?
You're welcome. Well, in Google, which is what I always use,
Okay.
I have the option to either type in Gmail and click on what comes up in the Google search, or I can click on that convenient little grid that gives me the mail icon.
There you go.
Or I could also click on the Gmail tab once I'm signed in. Okay.
So you're using a browser. That's what I'm trying to get at. Okay. Does anybody else not use a browser? Do you have like
I have an app on my phone as
That's
well.
what I do too.
Okay.
I already have set up in the street 2 months.
Yes.
Okay, so you use the app on your phone, you use the one native to the OS?
Yes. Correct.
Ugh, okay.
It works for me.
No, oh, okay. She's my girl right there, she knows, oh, don't use that one messes up all the time.
It has never messed up for me.
Probably because it's iPhone, but.
He is probably correct.
I'm gonna let you have that one.
Because since Google and Android,
Well, there's, like, I use Gmail, and I have a Gmail app, and I use the app, I don't use the native things. We're gonna talk about why here in a second. So as far as email clients, there's generally a few different ways that you can do this. There's POP, IMAP, and there's webmail. What y'all are describing to me is webmail.
well, Gmail's native to Android, so.
Right. It's also native to the app that they created, but.
This one?
We're
Okay.
both right.
We are both right. We're right in different ways. So, I want y'all to understand the difference between POP and IMAP. This is the thing, if I don't teach you anything else in this chapter, this is the thing that I want you to understand. So, show y'all a video on that.
Post office protocol.
Hi there. In this video, you'll learn the difference between the two most common incoming email protocols, POP and IMAP. POP, or Post Office Protocol, was created as a simplified way to download and delete messages on a remote email server. The latest version, POP 3, is supported by virtually all email clients and servers. Using POP, an internet-connected email client accesses a remote mail server, downloads all email to your local computer, and marks the messages for deletion on the email server. This means the messages you retrieve using POP can only be viewed in the specific email client on the specific computer that you downloaded them to. Once downloaded, you cannot access these messages via webmail or a different email client on another computer. Think of POP like a traditional telephone answering machine that uses tapes. Callers can leave a recorded message on the answering machine, but you can only listen to the message if you are physically in the same room as your answering machine and press play. Until you erase your messages from the tape, they remain available to replay at any time, but only from that answering machine. IMAP, or Internet Message Access Protocol, was specifically designed to free us from the limits of sending and receiving email from a single email client. In contrast to POP, IMAP allows you to log into any internet-connected email client or a webmail site and view all of the same emails at any time. In a constantly connected world, the ability to send and receive email from both email clients and webmail sites has made IMAP very popular. With IMAP, your email is stored on your provider's email servers until you delete it. While this makes email access convenient, some providers limit the amount of email you can store on their servers and may temporarily suspend email services if you exceed this amount. Think of IMAP like your remote digital voicemail. When a caller leaves a message using voicemail, their message is kept on a centralized computer data storage device, and you access the messages using the touchtones on your telephone or mobile. This digital storage in a centralized location means that you can access and listen to voicemails from any telephonic device that can generate touchtones. Your messages remain on your provider's data storage device until you delete them. However, most providers limit the number of messages you can store, and if you exceed this amount, callers may temporarily not be able to leave you a message. To decide which will work best for you, think about how you like to check your email. If you're someone who always checks their email from one location or on only one device, POP will work. However, if you're someone who checks your email from your laptop just as frequently as your mobile, and you need to be able to access it no matter where you are, then IMAP is a better choice. While POP and IMAP are not the only incoming email server settings, they are the most common. At GoDaddy, the type of incoming email server you have is primarily dependent on the type of email account you have and where.
Okay, so that's a commercial for GoDaddy. But I can't tell you how many businesses that I have gone into and they had POP email set up for one computer and they used Microsoft Outlook and Microsoft Outlook Docs. And it's like, guess what? Everything's gone. Everything. Whatever you had in your email is gone forever. So keep that in mind. Those differences are important, and no matter what level of tech you are in your field, you will come across that, and you will have to explain to people the difference, and you'll have to repair weird PST files in Microsoft Outlook so people have all of their email. Because POP is easier to do. So that's what most techs will choose, when really IMAP is probably preferable, as long as you have enough space to store messages. Now, with Google, your space is fairly unlimited. So with webmail clients, it does work a little differently.
Hi there. In this video, you'll learn what webmail or web-based email is. To learn about email clients, watch the video, What is an email client? All email travels over the internet and is stored on email servers. An email server can belong to a webmail provider like Gmail, an internet service provider like Comcast, or a web hosting provider like GoDaddy. You can think of an email server like the post office, where your mail is collected and stored until it's delivered to you. Webmail and email clients are two ways you can send and receive email. With webmail, your email is stored on your webmail provider's email servers and remain there until you delete it. To read or send email, you connect to the internet and log into a website that provides access to your email account. When you use webmail, you're directly accessing your email on your provider's email servers. Webmail is a powerful tool because it allows you to send and receive email from anywhere in the world using any device, as long as you have an internet-connected web browser. Popular webmail service providers include Gmail, Yahoo, and Hotmail. While this incredible ease of access and flexibility makes webmail very appealing, it's important to remember your email messages remain on your provider's email servers, so you must be able to access their website to access your email. If you don't have internet connectivity, or your provider's servers go down, you may not be able to access your mail. Think of webmail like a post office or P.O. box. With a P.O. box, you rent a mailbox at your local post office. The post office collects and keeps your mail safe until you're ready to retrieve it from your P.O. box. However, if the post office is closed, you can't access your P.O. box, and you have to wait until it reopens to retrieve your mail. In addition, some webmail websites may not be able to provide some of the advanced features and functionality you get from using an email client such as Microsoft Outlook or Apple Mail. So, webmail or email client? Not sure which is right for you? Some email solutions like Office 365 email from GoDaddy allow you to enjoy both the freedom of webmail access and the ability to utilize email clients like MS Outlook and Apple Mail.
So sometimes you can get webmail but have it go to an application essentially. What I really want y'all to understand is the keeping your inbox looking the same no matter where you're looking at it does not happen with POP. That is not what POP does. So that's a little bit about email clients.
No wonder it's not near as popular.
What? Popular. So when you're configuring an email client, sometimes we take for granted the fact that, for example, Google is free for education, or they have a lot of storage capabilities. Sometimes setting these things up, especially on mobile devices, is not that easy. Or finding the appropriate servers is a little more difficult. But generally, from the company that provides your email, you should get the type of mail server. You might even get a choice between the two, and I hope if you do, you'll choose IMAP. The account name and password, the DNS name of the incoming, and the DNS name of the outgoing. And a lot of times it'll just be like imap.google.com and smtp.google.com. But they'll provide that information to you, and then you will go put it in the software so that you can send and receive your email from it. Here's another kind of resource that we can serve up is FTP. So an FTP client is going to transfer files between a client and a server computer. If you turn on anonymous FTP, it means basically you don't know what user did what, which is probably not a good idea from a security standpoint. Or you could have an FTP site with security that requires you to log in to be able to get to something. I know, for example, this is an FTP client. This is Fire FTP, where you have your local computer here and you have the server here and you can move files back and forth. We use this a lot as instructors. They can't just put the resource material out on the internet, right? They normally have to do some sort of FTP something to make sure that it doesn't get to the students, it just gets to the instructors. So a little bit about sharing files and printers. From the server side, you have some sort of file and printer sharing device. A share is what we call a shared file or shared folder or shared printer. And then the services are installed and enabled by default, and it's normally very easy to do, but you are the one sharing it with other people, so that's why they call it a share. Microsoft File and Printer Sharing Service is something that can be turned on or off. From the client, the share has to be set up, it has to be enabled, and then the client has to have permission to go see the files or to use the printer that's on as part of the share. And that will depend on different permissions to make sure that that can happen. So you can view all the servers, and if you go to the network tab on your computer, you'll see all kinds of computers that have this enabled, including our domain computer. You can also use home groups for this. This is a really easy way to share things on a very small local network. So you can create home groups on all different kinds of versions of Windows. And you can, as long as you're connected to the home network, you have to have some different things enabled, but you can share files between local computers on your network, and maybe do things like share music if it's stored on different computers within your home network. And when you connect to the home group, as long as you're on home, then you will be able to do that. Okay, last part, common network problems. There's some built-in network diagnostics if your computer can't connect to the internet. It will pop up and say, do you want to run the troubleshooter to try to figure out what's going on? And sometimes it will give you some really helpful messages like, you don't have a cable plugged in. Oh, well, then you look and then it's, been accidentally unplugged or kicked out. So, for instance, this is telling you to restart your modem. You have a problem with the modem. There's a network utility in OS 10 where you can do different things that you would normally do in command prompt, but this time you don't have to know the commands, which is kind of cool that they did that. If you want to verify configuration, you can use ipconfig or ifconfig, depending on the operating system you're on. If you want to test with something specific, you can say ping and then put in the address of that thing. And then it's going to send out a request and listen back for a reply. If it's successful, you know you have communication. If it's not successful, you've got to stop and figure out why you don't have communication, right? But ping is very powerful. So for example, host 11, which is here, if it can ping itself, that tells us that it can make packets, right? It can make and receive packets. So that's one way that we can test using ping. If 11 can ping host 12, I know that it can talk to things within its same LAN segment, right? Because this is one LAN and this is one LAN. They're connected with routers. If host 11 can ping 192.168.1.1, that tells me it can talk to its router, right? If it can ping 192.168.2.101, I know that we can get it from here to a network on the other side, which tells me everything should be working perfectly, right? So just using 4 pings with that scenario would tell you that your network is completely up and running. Traceroute is something else that we use. You can say the command traceroute and then put in a website. And it's going to tell you every single hop or every single router it had to pass over to get to, in this case, google.com. Sometimes that can be interesting. So sometimes a packet will drop off at a certain point, and you know, hey, that's the point where it's broken. And a lot of times it's something outside your local network, so you know that, well, I just can't get to that website, I can't get to that resource, because my communication has dropped off in some place. With ping, you can also troubleshoot DNS. So I can troubleshoot google.com and figure out what the IP address for google.com is, one of the many IP addresses that's available. Then netstat shows us all of the active network connections on our computer. So in this case, I see that I have an established connection with that address using HTTP, which I believe means I have Google up in my browser. And final command, nslookup, is trying to determine if there's some sort of DNS problem. So you could say nslookup google.com and it would give you the address of google.com.